if based on the James Webb, that everything that we know is turning out to be false.
The Big Bang Theory says the universe started from nothing. Before that, there was no time or space. But what if time isn't real, and the Big Bang Theory is wrong? New findings from the James Webb Space Telescope are challenging the Big Bang Theory. They suggest the Big Bang might not be the universe's beginning, and time could just be an illusion. This surprising idea is supported by famous British physicist Roger Penrose. You might be curious how the James Webb Space Telescope supports the idea that time is an illusion. And if the Big Bang Theory is wrong, what other ideas explain the universe's origin and evolution? Let's explore. Our universe's journey began over 13.8 billion years ago with the Big Bang. But new images from the James Webb Space Telescope are shaking things up. These pictures, while amazing to us, have puzzled cosmologists and astronomers because they don't match the Big Bang Theory. This theory has been a cornerstone for many scientists. So this new data has really caused a stir in the science world. Experts like Alison Kirkpatrick from the University of Kansas are rethinking their past work. In these new JWST images, galaxies look strange. They seem too small, smooth, and old. This contradicts the idea that galaxies grow larger as the universe expands. Even star-filled galaxies appear tiny compared to what Hubble showed us. It's not just the size. The redshifts in these galaxies are higher too. This means they'd have to be tiny for what we see to make sense, which is pretty wild. Big Bang Theory fans expected to see densely packed galaxies, like Mighty Mouse galaxies. But JWST's images show galaxies like the ones we see today, not ones beaten up from collisions. Without big collisions, small galaxies can't become big ones like we thought. This challenges the idea of an expanding universe. Maybe there wasn't a Big Bang after all. Also, the ages and numbers of galaxies in the pictures don't match the theory. JWST is finding way more galaxies than expected, suggesting an earlier explosion, casting doubt on the Big Bang Theory. Time is a hot topic among scientists. Some say it's just something humans made up, and everything happens all at once. This idea challenges the belief that time always moves forward. Others suggest time might go backward, when the universe stops expanding. Imagine everything rewinding like a movie playing in reverse. What happens after this big crunch is a mystery. Some think the universe will restart, while others believe it might disappear. Some even think this cycle keeps repeating, creating many universes. Scientists are rethinking time, proposing a block universe where past, present, and future all exist together. Reality might be like a painting where everything is already there, but we see time moving forward. Scientists like Max Tegmark and Julian Barber have different views on time. This raises questions about Einstein's theories. What if he was wrong? Would dropping his ideas help us understand the universe better? In the history of science, doubts often lead to big changes. Copernicus challenged the idea of Earth as the center of the universe, and Einstein changed how we think about gravity. Will questioning Einstein lead to another breakthrough? Einstein's space-time theory has been dominant for ages, especially after we detected gravitational waves in 2015. But now, there's a new contender in physics. Enter quantum theory. Imagine a world where tiny particles can be in many places at once. Think of Schrödinger's cat, both alive and dead in a box. It's weird, right? But this quantum world doesn't fit well with space-time's smooth flow. Even top scientists like Sabine Hossenfelder see the clash. Einstein says gravity can't be in two places at once, but quantum physics disagrees. So, where does gravity fit in this quantum puzzle? No one knows. When scientists try to combine these theories, the math goes crazy. We're talking about numbers bigger than infinity. Now, physicists are looking for peace. They're searching for a theory that combines quantum magic with gravity's pull. Enter string theory. It suggests our universe is like a symphony of vibrating strings, no experiments needed. But some prefer loop quantum gravity. It says space isn't smooth but is made of loops. like stitches in fabric or pixels on a screen. Sounds good, right? But there's a catch. These space stitches are incredibly tiny, like a trillionth of a trillionth of a trillionth of a meter small. Testing this theory isn't easy. We'd need a particle accelerator as big as the Milky Way. But some smart people have a plan using supercooled cesium atoms to see if gravity behaves like a quantum force. In the vast expanse of space, there are tiny imperfections waiting to be found. When light travels from distant places, it moves through a lot of space. Even small flaws can have a big impact over long distances. Scientists have been studying bursts of energy called gamma-ray bursts from faraway places to understand the universe better. These bursts happen when huge stars die. But when we look closely at the light from these bursts, we find strange things that don't make sense. It's unclear if these oddities happen during the light's journey or are part of the bursts themselves. It's a real mystery. To dig deeper into this mystery, we might need to rethink our view of space. While Einstein thought of space as a stage where events happen, some scientists like Friedel, Lee, and Harmonic suggest a different idea. Space is like a dance between things. They say space is shaped by interactions, especially on a tiny scale. This new perspective could offer fresh insights. The modulus space-time theory is interesting because it might solve a big puzzle in physics. When we look at tiny particles, they seem to communicate instantly, no matter how far apart they are. This confused Einstein, but this new theory suggests that distance isn't just about physical space, but also about connections on a tiny scale. It's like feeling close to someone even when they're far away. Friedel, Lee, and Minnick have been thinking about this idea for a while. They're being careful but are excited about their progress. Their approach is to study the tiny world affected by gravity, instead of trying to understand gravity itself as other theories do. It's a different strategy, but they hope it will lead to big discoveries. Understanding space and time might seem like something only scientists care about, but it's important for everyone. Our whole world depends on knowing how things work on a tiny level. Even though the effects might not be obvious right now, they could shape our future. It's like expecting big changes when a new ruler takes over after a long reign. Scientists are working hard to uncover the universe's secrets and figure out what's next. Curious about the future of space and time? What are your thoughts on these groundbreaking theories? Drop a comment below, share this video with fellow explorers, hit that like button if you found it intriguing, and don't forget to subscribe for more fascinating insights into the mysteries of the universe.